Hi all, my name is Alek Ninashev. Today I'm talking to you from Lugano, Switzerland. I attended a conference named Vox Days, so this is my background, but actually I'm in my hotel room and I'm traveling together with my son. So just in case, I apologize for any background noises, and he's super opinionated about anything related to automation. So stay tuned for his opinions and Zoom bombing. Okay, today I want to talk about advanced code coverage with Jenkins, GitHub, and API mocks. Maybe you use tools like WireMock and Testcontainers. Actually, I contribute to many open source projects, including these ones, and I'm happy to share some bits. So again, I'm speaking to you from Lugano. It's a really nice place. And actually, if you're interested what I'm talking about, at this conference, I spoke about open roadmaps for your open source communities. So it's completely different culture talk. But today we are focusing on the technical side. I contribute to many projects, and I'm happy to basically squeeze in all of them in today's talk. One thing you might not have noticed, I've actually just changed my job on the 8th of January. So now I joined Gradle as a developer advocate and community builder for Gradle build tool. It's one of Java build tools, one of the most popular ones. And if you would like to share your feedback and opinion about these tools, or just want to contribute and need some assistance, feel free to contact me. I'm always happy to assist. And yeah, thank you. So today we will briefly talk about code coverage in Jenkins. Then we will dive into integration tests, discuss Checks API, and how we could improve developer experience and developer productivity using all these tools together. These slides are already public, so you can scan just QR code. I will pause it here, or you can see notes in the presentation, and the slide deck is already available. So you can find all the information here. Actually, this is a huge slide deck. I'm not going to show it mostly, but you can refer it, and there is much more information than I'm presenting today. Also, a few more demo links, etc. So let's get started. Also, if you have any questions, there is a Q&A chat. So I have just published the discussion on the community Jenkins.io. It's our forum. So if you have any questions or feedback, please connect here so that you can see all the information and additional conversation. Okay. You most likely saw me in Jenkins if you use this project. I'm a core maintainer. I used to be a governance board member for 4 years. I just stepped down in December, and I contributed to many other popular projects like Jenkins configurations code, Jenkins file runner. I organized a few Google Summer of Code projects, and also I organized quite a lot of online and in-person meetups in different locations. Now I'm rather on sabbatical because of the war in Ukraine, so I decided to prioritize volunteering over contributing to open source. Sometimes the choices have to be made, but I'm looking forward to return to Jenkins once the situation improves. So one thing I always ask when I talk about Jenkins is what you prefer, whether you prefer self-build or ready-to-fly tools. Because this is basically depends what we will choose. Jenkins inherently is an automation framework, so it wouldn't work out of the box. Instead of that, it provides a toolkit, or rather a framework, which you can use to build your own automation system, connect with other tools, and actually get a great developer experience. So yes, Jenkins is an automation framework, and it is extensible. And basically how it happens, you take infrastructure, you install Jenkins, connect it to backend services, let's say code scanning tools like Cobertura, or external repositories like GitHub or GitLab, and then install plugins, configure everything. And then if you serve it at scale, you also provide samples, demos, and documentation for your team. This is how you build a CI or CD system out of Jenkins. And for this talk is quite important because we will be using this system to actually provide better code coverage. And yeah, so as we know, for any frameworks, it might be quite difficult, and everything depends on the team. So in this particular presentation, the team automation is us. And let's speak about specifically about code coverage. I guess almost everyone saw code coverage best practices, maybe online, maybe on your projects. But now with continuous delivery, etc., code coverage is much less popular than it used to be before. At the same time, the tools are there and the tools have improved a lot. So in Jenkins, things also improved. So if you use Jenkins 10 years ago, you might remember things like that. Well, actually, it's not even 10 years ago. It's 6 years ago when Jenkins Pipeline was introduced, and you had to trigger a plugin by specifying class, passing parameters, and it has been super difficult to maintain. And basically, every automation team needed to provide a solution to their developers by taking components provided by Jenkins as a framework and building a pipeline that would address the needs of your project. So this is how it used to work. And of course, there were solutions like pipeline libraries that made it simple for developers, but still it was really complicated. And moreover, even if you manage to simplify it like on these slides, you would still hit different issues. For example, for parallelization, and if you talk about testing at scale, like integration testing, parallelization is essential if you want to see the results. So of course, this approach wasn't really feasible and we needed something else. So something else, it's actually coverage plugin for Jenkins. Its history started in 2018 when we were basically fed up with our own CI instances. We wanted to improve the experience. And we started a Google Summer of Code project specifically focused on providing a better code coverage API that could be reused by existing tools like, let's say, Coverity, sorry, not Coverity, Cobertura, JaCoCo, or maybe other tools like Istanbul if you use other languages. And this is what was project. This project was successful. You can find the report, all the demos, videos on our website. We actually document things quite a lot, so please refer to that. And what we did next, this plugin was released. Then it got quite a lot of user experience improvements. And in 2023, it was also replaced by a new coverage plugin, which is currently, well, this link is broken. So you go to coverage plugin, and here you can see the new plugin, which was released not so long ago. And this is a new solution that is based on the old code base, but actually provides a slightly different model by including things. And you can find that there is a lot of adapters supported like JaCoCo, Cobertura, Pit for mutation testing. And actually the previous version included even more adapters. These days, you can basically convert pretty much everything to Cobertura or JaCoCo format. So by existing scripts and additional Jenkins plugins, you can support most of existing tools. So this is what it is in the nutshell. And yeah, as I said, with changes, etc., some formats were discontinued. What we basically try to do in this case, first of all, we start from build and unit testing, and then you need to publish test coverage. And for that, of course, there is a step for Jenkins pipeline. You can also use freestyle jobs for all style setups, and you just pass command and specify sources where you need to extract the data. So basically you rely on a Maven, on Gradle to actually build the project and to collect coverage data. And the plugin just publishes it, analyzes, for example, thresholds, and provides additional information. There is a lot of advanced features. For example, you can have coverage charts, you can have advanced reporting. Of course, there is REST API for extract all the information. You can merge the reports and configure pretty much everything. So let me just show it live. So I won't go far. We have this coverage plugin. And for coverage plugin, if you click here, you can see that there is quite a lot of GitHub checks passing, and of course there is code coverage mode. So code coverage is implemented by Jenkins, and if you go to Jenkins, we can actually find a lot of information here. So this is basically a Jenkins report provided by the recent version of the plugin. And here you can see quite a lot of information, for example, line coverage, branch coverage. We also try to analyze complexity to provide some additional insights and guide refactoring of the code. And of course, you can have the information on the per file basis. Then, if you go back, we can actually analyze the data, we can navigate. So for example, here we don't actually get much information, but if you are using a complex structure with a lot of packages, etc., you can have hierarchical views of the information and hierarchical views of the statistics. So here it's quite simplified, but you can actually find a lot more if you reconfigure the plugin. So for example, one thing, we always have summary statistics that is available for our users. And here you can just go to the main build, and presumably there will be some statistics. Actually, here we built only main branch, and here you can find core coverage trends. If you navigate, you will actually get this report with more information. And we provide summaries, etc., etc. So all of that can be shown in the Jenkins web interface, and all of that is quite handy. What else you can do when you use this plugin, when you have proper code structure, you can actually navigate on the per class level, and you can even connect coverage to code like you normally do in coverage tools. It's a separate flag because it's super heavy, but you can actually navigate and see what lines are covered, what lines are not. You can also have differences between the builds, and actually it is helpful for analyzing. Let's go here, and yeah, we already presented that example of coverage plugin. We can also take a look at the Jenkins core. So it's basically our biggest project. And of course, we do code coverage for that too. So if you click here, you can see that our code coverage is a whopping 66%. So actually it's super low, but it happens if you have not so much information. And if you also have a lot of changes like resources, sorry, a lot of companies like resources that cannot be easily covered. Here, we also don't collect integration tests, etc., which are collected in another package. We will see it later. You might have noticed that when I navigate, I always click this button, and sometimes I just stay in the GitHub web interface because it's quite handy. And this is one of the features which I wanted to present today, because this is how normally developers would use code coverage these days. When you go to Jenkins, it means that something is already going wrong and you want to actually investigate the changes. So here you can see some information, etc. But normally you wouldn't go there unless something is completely wrong. And for that, it's fun to see this interface. So here you can see that for this particular commit, well, it's prepare for next development, so it's not something reasonable. Let's take another commit. Okay, fixed permission check. So it's a bug fix. And here, if you click this button, you can see that there is again something really basic change, and some models, etc., affected, but the code base change is minor. So basically, you don't have to test much. And this is what we get for the code. Going back to these GitHub checks, it's something I would like to present a bit later, but well, since you have the slides, let's take a look. So yes, Jenkins have an integration with GitHub Checks. It's provided by Checks API plugin and GitHub Checks adapter. So a few years ago, there was a demand to actually integrate properly and simplify use of Jenkins. And as I said, not going to Jenkins interface when it's not needed is the biggest advantage, because here you can see all the checks, etc. Same for the pull requests, for example. So when I submit a pull request to Jenkins, quite conveniently, there is a replacement by this plugin. So you can see that there is some checks, and these checks are specific for this implementation. So this is how we normally use Jenkins. We rely on these checks. And moreover, this plugin and other plugins can actually contribute to the code base if needed. How it's done? So how we do that? We actually leverage the existing system from GitHub. So a few of our contributors, including Uli Hafner, who's also author of many coverage plugin, Team JaCoCo, and a number of students, including Keja, they created the GitHub Checks API, and it was also a Google Summer of Code project, which actually provided us with really good results. And with this plugin that is still being used, and it quickly becomes one of the most popular plugins. So the idea is quite simple. You leverage Checks API. So this is what you normally see when you run GitHub Actions, when you connect other systems like TeamCity. You see these green checks, etc. This is called Checks API, and basically Checks API is limited to GitHub applications. So basically Jenkins can connect to GitHub as a GitHub application, and this is what was done by Team JaCoCo. After that, yeah, after you set up application, Jenkins can actually interact with GitHub in both ways, and it provides you with such checks. Moreover, here you can see that, for example, for Gradle, we also built with TeamCity, and it also uses the same checks mechanism. So the advantages, first, yeah, these summary reports so that you can see right inside the interface, and you don't have to go anywhere. And this is markdown support, so you can actually put quite a lot of information right there. And we do it in Jenkins, including trends, changes, etc. And actually, we also can inject annotations. So if you have code tracker, you can inject annotations right inside pull request, commits, and it will say that particular line is not covered. So for example, if we were looking at this change, if this feature was enabled, and for example, so yeah, again, this is not very relevant. We can open something with code. So for example, here's a bug fix from JCGleek, one of the most active contributors. So if we were enforcing code coverage, here, if there was a line without coverage, we could actually get just a flag right here from Jenkins that would be saying that something needs to be changed. So it's a direct integration, which is super helpful. And this integration also replaces some features like code browsing in the coverage plugins. So it's quite handy. And again, this is something I would recommend you to do if you use GitHub. For the plugins like GitLab, there is a similar functionality. So if you go to plugins Jenkins.io, here you can see that, for example, I am not sure how it's called, maybe GitLab checks. No. Oh, it's just inside the GitLab plugin. So you can see that there is also quite a lot of plugins for GitLab, and there are plugins like violation commands, etc., that also push a lot of information right inside GitLab. So what I'm presenting is actually not limited to Jenkins. You can get similar functionality. Okay, and it's not limited for GitHub too. Let me show how we actually implement it, because you can see that there is, let's take an average plugin, let's say, many of you probably use configuration as code plugin, right? And here we have quite a standard build pipeline. So yes, we have Jenkins file, but this Jenkins file is quite specific because normally you would see a lot of lines, but here it's just simple. It's just several lines of code. And here you can see that we invoke build plugin method, which comes from a library, which actually are quite flexible. So this is a Maven project, and it calls this function. But for Gradle projects, it's basically the same. So if you go to Gradle plugin, if you click Jenkins file, you can see that there is a build plugin with Gradle. And again, we just pass the JDK version, timeout, and everything magically builds. And here you also get checks, etc. So basically, the integration is very same. And how it works in practice. So Jenkins, we of course use Jenkins for the majority of use cases, and we have our own pipeline library that is actually a part of GitHub Jenkins infra organization. So the one which we use for all kinds of automation and the website, etc. And here's pipeline library. So this is basically our code base that helps us to build Jenkins projects. And then you can see that there are multiple steps. And one of the steps is build plugin. So build plugin with Gradle, build plugin with Maven, and you can see that there is quite a lot of code, but this code is isolated, and basically it reads configuration, which is passed either by arguments or by configuration file, and then they executes the build step by step, and also does all the reporting that is needed. For example, coverage, spot bugs. Yeah, coverage is just a few lines of code. Also, recording issues is basically we parse logs and publish the results, archive artifacts, and you can see that everything is embedded once you have a standard template. For example, if you build Java projects with just Gradle or just Maven, it's quite straightforward. For Maven, it's basically the same. Maybe the file is a little bit bigger because we leverage parent poms, etc. But ultimately, it's the same. So this is how we build. And once we build it, everything gets published. So we use existing plugins, etc. So basically, it's just a few lines of code. So this is what I wanted to show basically for unit tests. And for integration tests in Jenkins, we actually use our own libraries, but we have recently started adopting test containers. We have been a long time user of WireMock, and integration tests, they're actually quite helpful if you want to improve code coverage. Why? Because many features are just not covered by unit tests, or it's really hard to reproduce that. For example, if you have multiple technology stacks, tool chains, some platform-specific code, you might have many teams. Sometimes there are situations that cannot be easily reproduced. So developers, including many watching this video, are likely, hey, integration tests. It's massive amount of time if you do it wrong. And more problem, it really impacts your developer productivity and velocity because you have to wait a lot. These tests are not fast. So you push it, then you wait until the build passes in Jenkins or not, and then something breaks, something always breaks, and then you have to fix and rebuild everything. And when you rebuild, you also submit your pull request and you again wait. So it takes time, and actually it may take infinite time. So sometimes when there are complex checks, whether the additional requirements like check style, etc., it really takes ages to get the checks green. And the problem, in my opinion, is in the fact that integration tests are there, they're heavy, they require additional builds, and they delay you. So if we could resolve it, it could be better. And this is actually what you can do with modern Java tooling. And the tools I really like are Testcontainers and WireMock, which basically help you to shift left integration testing. So instead of having separate integration tests, we can use existing Java frameworks to basically provide the same experience like unit tests, but actually by doing integration tests. And there are two approaches. One, testing about against simplified instance, if you can put it in Docker in a container. So this is what Testcontainers does. And if it's not possible, if the application just doesn't exist, yes, there is WireMock, which basically does the same. So these two approaches, which are super handy, and these are the tools that I wanted to briefly talk about today. So yeah, we can actually improve the experience for all kinds of integration testing. So test containers, most probably you have already tried it because test containers is getting super popular and many projects, including Jenkins, use it. So you can see that there are basically Java, Go, .NET implementation, also some additional features for Clojure, for Elixir, Haskell, if you wish. And for all these implementations, there is actually quite a lot under the hood that you can leverage. But the principle is very simple. You use containers to create a clean environment, normally in Docker, but you can use Podman and other tools. And basically, this clean environment exists just for your session. Then it can be recycled so that you can use other things. By the way, I'm maintaining of test containers for C++, so ask me if you're interested. And also, Testcontainers offers models for many popular projects, including local stack. If you, for example, run with public clouds, WireMock, most of the databases, most of queue and message bus solutions. So yeah, you can find a lot of tools, and for these tools, you can basically get automated deployment, additional API for proper configuration, additional API for certs. So it actually saves a lot of time in development. And the thing that people do not normally understand is that actually it's very fast. because you get on-demand bills, you can have caching, you can suspend containers on demand, and also the termination and release of resources is fully managed by Testcontainers. So you write the things really simple. Let me just show you an example. So here, if you go to models, well, we can take, for example, Dapper. One example for Dapper isn't particularly helpful because you just started. Let's see whether we have something more detailed. Maybe here. No, it's basically the same. So people here just provide the very basic starter guide. So let me show you, but I think you can also find something in documentation. There is a lot of different guides for different tools you can find. And for example, yeah, so there is WireMock. WireMock, of course, we will skip for now. But for example, if you use Micronaut, if you use Kafka, if you use Spring Boot, if you use Python or other tools, you can find a lot of information and examples here. And for example, for testing AWS, we can again use local stack, which is has a model, and then you can just write a short piece of code, or maybe not so short. So here we set up templates, etc. And then eventually we should actually start using test containers, right? Oh, yeah. So this is basically a Spring Boot application. Second. Yeah, okay. So this was a very important comment of this meeting, but yeah. So you can see that there is container that is being provisioned. So it's local stack container, we configure it, and then we do some configuration and just run our code. So this is how a really big test container may look in practice. And for example, if you like Golang, I will jump the code a bit. And here, for example, WireMock, test containers, Go. So this is basically the project that I created and maintain. And you can see that basically this is the same test containers that is being used for Golang. And it's also quite simple in terms of code and implementation. So you just write a test, you say that you need a container, then handle the request, and then basically you can use it in your test. So here just send an HTTP request and then validate the response. So basically pretty much like every other JUnit test, and it's platform independent. Same for databases, other tools. So yeah, this is the power of test containers. WireMock, as I said, is a tool for API mocking. Yes, there is a model that also allows to use WireMock with test containers. And the principle is quite simple. You send a request and get a response, and WireMock is a server that replaces your implementation. So you get rid of third-party dependencies, etc. You can use it in Java, you can use it in other projects, and it's basically quite straightforward. It's again a bunch of rules and adapters. And there is quite a lot of advanced features like response templating, recording, fault injection, which you can use. And there is quite a lot of tools. WireMock is available for different projects and ecosystems and way beyond Java. So for example, there is WireMock for C++, WireMock for Golang, for .NET, Python, and pretty much other language. And yes, there is Gradle implementation tool. It's still not merged to this pull request to the website, but stay tuned. So and yeah, for these tools, you can actually use them together. So there is a WireMock model for test containers, which offers implementations for 5 languages now: Java, Golang, Python, also Node.js, and recently C++. And the usage is very simple. So you just say you need a test container, then define how this container is used, and then write a test that would use this container and provide some results. So I have a few minutes, so I will just show you how WireMock uses it on its own. Actually, we have an inverted use case. So there is WireMock Docker, which is basically our official Docker image. And if you go to integration tests, you can see that integration tests are written in Java, so they use Maven. And in sources, you can see that there is basically test. And there is a test suite which uses WireMock and test containers to run automation and validate that this image is correct. So here you can see that we use WireMock image, that we provide some samples, etc. And this is basically test configuration that would be used in our test run. And when we run a real test, so for example, here we run a smoke test. So here we say that we would be using this WireMock. We will be also passing some configuration files for WireMock that basically define the behavior. And then we just run a test that uses this file and assumes that WireMock is there and acts as a service. So here, for example, there are these resources. They're really simple. So you just say get and handle a request. You can also put the data in JSON, XML, etc. to automate things. So this is the example. And there is Danny, do you want to present on your own? Okay, so we added some live to this recording, or probably I will cut it. Let's see. So then there is other tests you can find, for example, asynchronous things, etc. They are basically written the same. Then okay, so there are many other examples. Then you can follow, and you're getting information from there. So this is how it looks like, and actually it's quite simple. We can reuse them, and when we run them, in this example, I just use GitHub action. In this example, I just use GitHub action. Okay. Are you finished? Okay. So I will definitely cut this part. Yeah, let me check. Oh, man. Okay. Oh, no, welcome back. Okay, so a few other items that I wanted to mention before things go completely sideways. So yeah, we can inject failures and edge cases. So here, for example, we can use WireMock as a proxy to improve the test coverage even more. For example, if you want to trigger an error on your test client, then you can inject tests that can be really produced by real API provider or by test containers. You can record the behavior and use these records for additional asserts or guide the behavior. You can use it for chaos engineering, for contract testing. And if you use existing tools like existing API protocols like OpenAPI, you can verify behavior against OpenAPI specification. So for parallel testing with the new plugins, actually it's super straightforward. You just include everything, and everything is available beyond Java. So for example, code coverage plugin. Yeah, so you can run the same in Python. You can run the same in Golang as I presented before. So there is quite a lot of different approaches to use it. So for Python, it's basically the same I presented. There is test containers with a lot of extensions, models, and there is WireMock that also supports all of the things for different languages and frameworks. So just to wrap up, I would like to thank all Jenkins contributors, all WireMock contributors, specifically Uli Hafner, Team JaCoCo, Shenyu, Heji, who implemented the majority of the foundations for the code, and thanks to all participants of the Google Summer of Code project that make it happen. So to summarize, so Jenkins is one of actually strongest platforms for continuous integration because it includes powerful reporting capabilities not available in other tools. You can use a special tool for coverage analysis, but having an CI is also quite handy. And code coverage API, which we added, supports parallelization, supports emerging reports on demand, which is super useful for multi-configuration testing. So you can actually trace what is covered, for example, for different platforms, and identify the pieces of code that still needs to be adopted. And yes, technology stacks can be supported, not just Java. If you wish to do C++, plus do that. There is JCover project for JavaScript, etc. There are also converters that integrate with Cobertura, and integration with GitHub Checks is also quite helpful. So just do integration testing, shift left this integration testing, and of course, do API mocking and consider tools like WireMock as test containers that can be quite helpful. So for these demos, you can find actually a lot of examples that I presented today briefly. So there is Jenkins repository, pretty much every Jenkins repository uses either Gradle or Maven. It has quite a lot of CI runs, not just code coverage, also static analysis, JUnit tests, check style. You can find a lot of things. Then, of course, consider shifting left your integration testing. WireMock and Testcontainers. There are two projects I would highly advise. There are other projects like Microx you can consider. And whatever project you use, whatever your project you use with Jenkins, please share our feedback, the feedback. So there is quite a big community. And as I mentioned, there is a big forum. We have recently moved to Discord. So community Jenkins.io is where you can find almost everything. And there are still other Gitter channels, RC channels, GitHub issues for pretty much every plugin. So enjoy, and we are happy to help the community. If you wish to contribute, all projects also have contributing guidelines, and they will be happy to accept your patches. And it's not just code, documentation, tests, automation, etc. All of that would be much appreciated. So that's it. Again, if you want to ask any questions, there is community Jenkins.io where you can find the things. And I hope this quick presentation was interesting. I actually have a lot more content I wish to show. Even these slides are not exhaustive. So if you wish to have something, contact me. I can do a specific presentation or a specific demo upon your request. Thank you and have a nice day.